Hello dear students, I am Sumitra Shrava, TGT Science KVS. In today's video session, we shall take up part 3 of chapter 1 Matter in Our Surroundings from class 9th Science. Topics to be covered in today's session are change of state of matter, effect of temperature and pressure, latent heat, evaporation and the factors affecting evaporation. The learning objective of today's session are to help learners understand that matter can change its state, to enable learners to explain the effect of temperature and pressure on the state of matter, to help learners grasp the meaning of latent heat, to help learners list out the factors affecting evaporation. Can matter change its state? Well, we all know from our observations that water can exist in 3 states of matter, that is solid as ice, liquid as the familiar water and gas as water vapor. So, let us consider the following questions first. What happens inside the matter during this change of state? What happens to the particles of matter during the change of states? How does this change of state take place? So, dear students, firstly let us see what is happening inside the matter. During the change in state of matter, the following changes are happening inside matter. Changes in molecular forces of attraction, changes in distance between the molecules, change in kinetic energy of the molecules. Now, coming to the second question, that is what happens to the particles of matter during the change in state? Well, the particles are either drifting away from each other or they are coming closer to each other. This is happening due to the change in kinetic energy of the particles. We have already learned in the previous sessions that the particles of matter are continuously moving, that is they possess what we call kinetic energy. If the kinetic energy increases, then the particles will move farther away from each other, creating more intermolecular space. On the other hand, if the kinetic energy decreases, then the motion of particles will eventually slow down and they will come closer to each other. The important question that arises after all this discussion is, what is causing all these changes inside the matter? This can be explained by considering two important factors, temperature and pressure. Change in temperature or pressure can cause the particles to either drift apart or come closer. In the same way, change in pressure can also have similar effects. Temperature is the degree of hotness or coldness of a substance. To understand the effect of temperature on the state of matter, let us perform an activity. Take about 150 gram of ice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with the ice. Start heating the beaker on a low flame. Note the temperature when the ice starts melting. Note the temperature when all the ice has converted to water. Record your observation for this conversion of solid to liquid state. Now, put a glass rod in the beaker and heat it while stirring till the water starts boiling. Keep a careful eye on the thermometer, reading till most of the water has vaporized. Record your observations for the conversion of the liquid state to the gaseous state. Through this activity, we can explain the changes occurring in the following chronological manner. The previously mentioned activity can be explained in the following way. On increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating. with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed positions and start moving more freely. A stage is reached when the solid melts and is converted to a liquid. If rise in temperature continues, then the liquid will further change to gaseous state following the similar order of events as in the case of solids. Now, let us discuss about melting point and boiling point. The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. For example, the melting point of ice is 273 Kelvin or 0 degree Celsius. The temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. For example, the boiling point of water is 373 Kelvin or 100 degrees Celsius. The process of melting, that is change of solid state into liquid state, is also known as fusion. During the change of state, it is observed that when a solid melts, its temperature remains the same. So, a question arises here, where does this heat energy go? The heat energy gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the content of the beaker and is known as latent heat. It is the amount of heat released or absorbed during change of state of the substance. Its definition can be explained as the amount of heat energy that is required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So, particles of water at 0 degree Celsius or 273 Kelvin have more energy as compared to particles of ice at the same temperature. Now, dear students, let us try to understand the effect of change in pressure on the state of matter now. Applying pressure and reducing temperature can liquefy gases. Solid carbon dioxide CO2 is stored under high pressure. Solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid or gas. Atmosphere is a unit of measuring pressure exerted by a gas. The unit of pressure is Pascal. 1 atmosphere is equal to 1.01 into 10 raised to the power 5 Pascal. Now, let us move further with the process of evaporation and the factors affecting it. We have already learnt about evaporation in junior classes. The phenomena of changes of a liquid into vapor at any temperature below its boiling point is called evaporation. Evaporation is a surface phenomena. Evaporation is influenced by certain factors, namely surface area, temperature, humidity and wind speed. Evaporation is directly proportional to surface area. We know that evaporation is a surface phenomena. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out, which increases the surface area and hence the clothes dry faster. Evaporation is directly proportional to temperature as well. With the increase of temperature, a greater number of particles get enough kinetic energy to go into the vapor state. Evaporation is inversely proportional to humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. That is the reason clothes don't dry out on a rainy day. Evaporation is directly proportional to wind speed. It is a common observation that clothes dry faster on a windy day with the increase in wind speed. The particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. Evaporation causes cooling effect. In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surroundings to regain the energy lost during evaporation. This absorption of energy from the surroundings makes the surroundings cool. This is what happens when we pour some acetone or nail polish remover on our palm. The particles gain energy from our palm or surroundings and evaporate, causing the palm to feel cool. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during evaporation, the particles at the surface of the liquid gain energy from the surroundings or body surface and changes into vapor. The heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. Now, let us have a quick recap of the points learned so far. During change of state of matter, particles are either moving towards or away from each other due to change in kinetic energy. Temperature and pressure determine the state of a substance, whether it will be solid, liquid or gas. Evaporation is a surface phenomena affected by surface area, temperature, humidity and wind speed. It's time for an assignment now to practice and solidify the concepts further. Now, answer the following questions. Question number 1. Why should we wear cotton clothes in summer? Question number 2. Why an earthen pitcher is preferred over steel pitcher in summers? Question number 3. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Question number 4. What produces more severe burns, boiling water or steam? Question number 5. Arrange the following substances in increasing order of forces of attraction between the particles: water, sugar, oxygen. With this, we have now come to the end of today's session. I hope you have enjoyed it. Thank you very much.